Okay, so we've got to keep this equation in balance. So if I add 10 to both sides, the new equation would look like this. X plus 13 is equal to 24. Okay, that equation, the new equation, is the same. It's still in balance. I'll still have the same value of x to solve it. Okay, I could equally divide both sides by 2. Okay, if I divide the left by 2, I'd have to divide the right by 2. I added 10 to both sides. I don't know, I'm just saying it's still balanced. Keep going. 24 divided by 2. So 24 divided by 2 is 12. On the left hand side, you have to be careful a bit here. If I'm going to divide the left hand side by 2, I better do it to everything on the left hand side. So in theory, I would have to use brackets like this and probably write 2 underneath. You have to divide all the terms on the left by 2, not just one of them. Okay, someone mentioned before, why did I add 10 to both sides? That was an illustration. In actual fact, I want to try and make x the subject, and that just means get x by itself. That's what I'm trying to aim to do. So where I've got a plus 3, I want to undo that plus 3 by removing it by subtract. So there's your seesaw, minus 3 from the left, minus 3 from the right. It's still perfectly in balance, and 14 minus 3 becomes 11, and 3 minus 3 becomes nothing, and I'm left with x on the right, so x on the left and 11 on the right. And it works, because if I substitute 11 back into here, 11 plus 3 is 14. That's the most basic problem you'll ever see this year. If I jump down to question 3 on the same page, it reads 5x, this is the next most basic question you'll ever see, equals 35. At the moment, guys, don't talk. At the moment, the equation is directly in balance. To undo, keep an eye on the board, to undo this, I have to use division, because in between the 5 and the x there's a multiplication, right? Remember, the objective is to get x by itself. To get x by itself, I have to undo the times by 5. To undo a multiplication by 5, divide by 5. To both sides of the seesaw. The 5 times by 5 divided by 5, the 5 actually cancel themselves out. And 35 divided by 5, the answer is 7. Substituting 7 back into the original equation should be a test. 5 times 7 gives 35. Next question.
that one?
Number 18. X over minus 2 equals
Equals 10.
equals 10. Okay, that's question 18. This x has been divided by 2 to undo at the moment the equation's in perfect imbalance. To undo a division, what do? Times both sides of the equation by 2. Okay? Actually, by minus 2. Because divide by minus 2, you better multiply by minus 2. That leaves the left-hand side of the equation just as x, is what I'm trying to do. And it leaves the right-hand equation, side of the equation, what's minus 2 times 10? Negative 20. Check. Minus 20, back inside x. Minus 20 divided by minus 2, answer? Minus 20 divided by minus 2 is 10. Look, it works. Next page, on page 45, it reads, the first question reads 2x plus 4 equals 18. Can you see that? 2x plus 4 equals 18. This is question 1 on page 45, right? Two-step problem. At the moment, the equation is perfectly balanced around the equal sign. Perfectly. If I do something to one side, I better do it to the other side, otherwise you're going to imbalance the equation and ultimately get it wrong. Same principle applies. I'm trying to get x by itself, so I know what x equals. Think about what happened to that x. It was first multiplied by 2, but then 4 was added. I have to undo that in the reverse order that it was done. So my first step is not to divide by 2, it's to minus by 4 both sides. Okay? Both sides of the equation. That will get rid of that. That'll get rid of that 4. And I'm left with 2x on the left is perfectly balanced with 18 minus 4. What's 18 minus 4? 14. And now I'm down to a one-step problem. I have to undo times by 2 by dividing by 2. X equals 7. The 2's cancel and 14 divided by 2 is 7. Check that answer. 7, good. 7 into there. 2 times 7 plus 4. It works, right? Got it? One more. Question 4 reads x over 3 plus 2. Equals 7. With me? Question 4. What should I do first? Times both sides by 3 or subtract both sides, 2 from both sides? What should I do? Should I multiply both sides by 3 or should I subtract both sides, 2 from both sides? Definitely subtract 2. And that's because if you think about what happened to x, it was first divided by 3, then 2 was added. I have to undo that in the reverse process. So subtract 2, then you can multiply by 3. Both sides, take away 2. On the left-hand side, I'm going to be left with x over 3. On the right-hand side, I'm going to be left with 5, right? Now what? Yeah. To undo the divide by 3, I have to times by 3 both sides. Right? X divided by 3 times by 3, you're left with just x. And 5 times 3, you're left with 15. Check your answer. 15 goes into the problem. 15 divided by 3. 5 plus 2. It works. Well done.